All right, so in Chapter 10, Section 1, we start the idea of hypothesis testing. Hypothesis testing is we want to test something that we believe might be true versus what's given. The null hypothesis, also called the HO, the null hypothesis, is what's believed, that the mean is 8. We think something different's going on, right? So maybe the mean is not equal to 8. So this is our null hypothesis. This is our alternative hypothesis. So when you're looking at this question, what type of test is being conducted? If it's a not equal to, that means it's two tails. If it's a less than, it's a left tail. It's a greater than, it's a right tail. So we have a two-tailed test. And then what parameter is being tested? Well, the mean, right? The population mean. We're going to be dealing ones with population means and proportions are the ones that we're going to be dealing with. We will not be doing the standard deviations. So this would be a mean. Again, there's a lot of definitions and more reading in this section, but nothing too computational yet. That'll come. We'll use StatCrunch in the near future. Which of the following is a hypothesis test to be conducted? So 6 years ago, 12.7% of registered births were to teenage mothers. A sociologist believes that the percentage has increased. So that gives us an idea. For our dealings with, the null is always going to be an equal to statement, so it's equal to 0.127. And the alternative, they gave us a clue that and they said increased, so that means a greater than. Next part will say, which of the following is a type 1 error? So again, there's definitions in here that talk about a type 1 error and a type 2 error. We always have the opportunity to make a mistake when we do statistical research. We're not doing a census, we're doing a sample. So with sampling, we could find out something's incorrect. So if we reject the null hypothesis when the null hypothesis is true, this is a type 1 error. So we reject the null. So like on the last example, we would say, hey, we don't think the mean is 8, but the mean really was 8. That would be an example of a type 1 error. If we do not reject the null, and we should have, this is a type 2 error. So there's a nice little chart in the book, but describing a type 1 and a type 2 error. So for this one, rejects the hypothesis that there is 12 when the true percentage is when it is the true. So it's not greater than or less than, it's just we rejected it that it was equal to 0.127 when that was true. So we're not dealing with a greater than or anything here. When you think of type 1, type 2 errors, you could always think of with a jury. So there's guilty and not guilty. So there's rejecting the null hypothesis or fail to reject the null hypothesis. If you convict someone, there's always a chance that you're wrong. If you let them go, there's always a chance that they're guilty. So similar ideas with a jury, something that might make more sense. So which of the following is a type 2? So we fail to reject the hypothesis, and we should have. So fail to reject when the true percentage is greater than 12.7. So this is what we should have done. Again, we always have the opportunity of being wrong. And one more example from this section, again mostly words. So this one's dealing with means. So according to a report, the mean monthly cell phone bill was $49.95. So this in the past, this is what we believe it is, but they think it's less today. I don't know why. I think mine's gone up. But that the mean monthly cell phone bill is less today. The null hypothesis is not rejected. Okay. So, this is the null. The less than is the alternative. So if this is not rejected, that means we really think it still is $49.95. So there is not sufficient evidence to conclude that the mean monthly cell phone is less than its level 3 years ago today. If we say that there is sufficient evidence, that means that we are rejecting the null.